Hi everyone, my name is RM Aresh Pawan. I'm studying in Sri Venkateswara College of Engineering. Today I'm going to explain you about the concept called pumping lemma and its application from automata theory. Today's agenda: introduction, types, examples and advantages, applications. Coming to introduction, pumping lemma is used to prove that language is not regular. It can not be used to provide that a language is a regular. Types of pumping lemma: context free language, regular languages. For regular language, pumping lemma is used to prove that a language is not regular. It cannot be used to prove that language is regular. In simple terms, these mean if a string v is pumped, that is, if v is inserted any number of times, the resultant string still remains in L. Pumping lemma is used as a proof of irregularity of the language. Thus, if a language is irregular, it always satisfies the pumping lemma. If there exists at least one string made from the pumping which is not in L, then L is surely not regular. The opposite of this may not always be true. That is, pumping lemma holds it does not mean that language is regular. Example: Q naught is going to Q and Q1. U and V is pumping. Coming to pumping lemma for regular language rules. Steps. First step is, suppose language is regular, then we can make finite automata. Let's suppose finite automata of language is of 10 states. Take a word of a length greater than number of status. Divide word into three parts, x, y and z, in a way that length of x is plus length of y less or equal to n. X and z can be null, but y cannot be null. Length of y greater than equal to 1 will decide language is not regular. Examples: language L of all strings ending with ABA if sigma A comma B. Suppose language is regular, so the finite automata concept of the language is of 7 state. Take a word from L of length greater than 7, x being AAB and y is AA and z is AABA is equal to W. Length of x is equal to 4, length of y is equal to 2, length of z is equal to 5. Also, length of x plus length of y less than 7. Therefore, 4 plus 2 is less than 7. Increase power of y. Last step. X is equal to AA, triple A, B. Y is equal to double A. Z is equal to double A, B, A. W is equal to X double Y, Z means A, triple A, B plus 5, 6 B's plus A belongs to L. W is equal to X, Y, Y, Z belongs to L. Pumping lemma of context-free language. Pumping lemma is used to prove that language is not context-free. Pumping lemma of CFL states that for any context-free language, L it is possible to find two substrings that can be pumped any number of times and still be in the same language. For any language L, we break its strings into 5 parts and pump second and fourth substrings. Pumping lemma here also is used as a tool to prove the language is not CFL, because if any one string does not satisfy its conditions, then the language is not CFL. Pumping lemma for CFG rules. Let L of G is CFG, then the following condition must be satisfied. Steps. Every Z equal to L of G with the Z of greater than N. N is a natural number and Z is equal to U V Y W X Y. For string, divide into 5 parts. Example. Prove L is equal to A power I, B power I, C power L. I is divided by I less than greater than equal to 1 is not CFG. Assume L is CFG, N is natural number, L is equal to ABC, AA, BBC, AA, BB, BBC, 3, 4As, 4Bs, 4Cs. N is equal to 10. Z is equal to 4As, B, 4Bs, 4Cs. V and X contain some symbols. U is equal to double A, V is equal to double A, W is equal to 4 Bs, X is equal to C, Y is equal to 3 Cs. U, U into V power I into W into X power I into Y equal to L, capital L and K greater than equal to 0. K is equal to 1 contains 4B, 4As, 4Bs, 4Cs equal to L, where K is equal to 2 contains 5As, 4Bs, 5Cs, not equal to L. Coming to advantages of pumping lemma. Pumping lemma for regular languages. The fact that all sufficiently long strings in such a language have substrings that can be repeated arbitrarily many times, usually used to prove that certain languages are not regular. Pumping lemma for a context-free language, that the fact that all sufficiently long constraints such as language have pair of substrings that can be repeatedly arbitrarily many times, usually used to prove that certain languages are not context-free. Pumping lemma for indexed language. Applications of pumping lemma. Pumping lemma is a negative test. It can be used in application like showing an invalid move in game of chess. As well, move may not be obey rules of games. Application of pumping lemma are pumping lemma can be applied to prove that inputted move is invalid. Moreover, some power of situations also use this lemma determine cutoff temperature to be kept in furnaces. For an example, say pumping lemma can answer to why the temperature should not go beyond 250 degree etc. Those in nutshell, pumping lemma has variety of applications in practical engineering. References. Thank you.